Hi there, this is TempDev Podcast, where we discuss embedded Linux, IoT development, and anything else we might find interesting. Your hosts today are Cliff and Cam. How are you, Cliff, today?
Yeah, pretty well, Kim. How are you doing?
Very well.
Good.
Today we have an interesting topic, and it's a question: why open source for product development? I know Cliff is very passionate about it, and we'll talk about what his insights are, and we'll go along. So, first off, why open source for product development, Cliff?
Yeah, this is a question as I work with companies building products, and a lot of them come from backgrounds where they have not used open source a lot. So this is a question people ask and people struggle with, and kind of before this I wrote a blog article on this, which we'll also link to in our podcast notes.
Hmm.
And through this article, I feel like I've learned a few things. And as we look at product development, there's a lot's changing anymore because we use more complex technology stacks. So there's five perspectives I came up with: value, change, complexity, control, and culture.
Mm,
So those are just different ways to view product development, different concerns different people may have, and then kind of how they tie into open source development. So
that's interesting. So, as we know, I think if you look at the stacks we have today, if you consider about the kiosk browser stack we have, then your statement is very right that there is so much of complexity that goes in. Um, from software perspective, and then there's the hardware piece, and then the whole product life cycle. So it's quite a bit complex in there. So
yeah,
uh,
for instance, we did some line counts the other day, and Chromium has 35 million lines of code in it,
wow.
and the total kernel source size is like 30 million lines, and of course, only a small subset of that gets compiled for each platform. But I suspect for Chromium, a good bit of that gets compiled
Mm,
to build a browser. I don't know the details, but um,
right. So yeah, I think that's very true, and it's not getting lesser any day. It's just um, compounding.
mhm.
So how do you define? So I think you mentioned about um, some facets of product development or perspectives, and you said about value and change, complexity, control, and culture. So how do you expand on something like, say, value?
Yes. So value is basically, in the end, we need to deliver value to our customers. So as we're developing products, we're trying to increase the value, find ways to deliver more value faster. And value in software is hard to quantify, and the breakthroughs are difficult to predict, um, because there's um, there's some nonlinear effects there, because we're not constrained by physical constraints. Like, it doesn't cost anything to duplicate software.
Hmm.
Computers are very powerful, so they can run more software than we can write in multiple lifetimes. Unlike an old microcontroller that may only have 2K of ROM or something, a modern computer, we can write software for years on end and not fill up a computer. So, and then algorithms, there's really no ceiling on algorithms. There's always a better algorithm. It's kind of like human memory. There's always a way to improve it or expand it. So, these are the types of things we challenges we have when we're trying to deliver software value.
Yeah, yeah. I think if you look at the buzzword with generative AI, but if you look at how quickly the algorithms have evolved over a period of time, that's basically the unboundedness of the potential that software brings in. So very well said.
Hmm.
So as we talk about the breakthroughs and the iterative nature of developing software being easy, it also means that it could get complex. So first of all, what is complexity? Is it something like I create a software and then it is complex, or how do you peruse through that word of complexity?
Yes, there's two types of complexity. I classify them as, the one is accidental complexity, and
Hmm.
that's kind of an artificial human created complexity that we don't want. The other is inherent or necessary complexity, and that's just the complexity required to get the job done. If you look at any system in the human body, it's incredibly complex. Let's just say, for instance, the muscle system. There's many muscles in all different arrangements and positions, but all of those are necessary for the human body to move gracefully. You can't, if we injure ourselves, we quickly learn that all of those muscles are necessary. So that's what we call necessary complexity. And as these systems do more, collect large amounts of data, run AI algorithms, communicate over networks, display complex user interfaces, these systems all have to be complex because we're doing a complex job. And as we've mentioned, the complexity is just increasing at a very fast rate. So we have to have a way to manage all this and deal with it.
Hmm. So it's a challenge. And
Yes. Mm-hmm.
and if you look at, like, folks don't write spaghetti code. That's accidental complexity.
Right. Yes.
Um, so complexity is getting us, and then there is the rate of change, or how do you define that aspect of product development?
Yeah. With the advent of open source software, the internet, and widespread collaboration, there's really, things are moving fast, and the number of new open source projects that are coming out is staggering. You look at the rate of change in the Linux kernel and the number of lines of code that are written that go into that project. It's just, again, staggering the amount of development that's happening. So this change is happening very fast, and we can look at it two ways. We can look at it as a negative, like, I can't keep up, or wow, look at this value we can use.
Hmm.
And this change, software, the fact that software can change and deliver more value over time is one way that software is different than hardware, because with hardware we build a product and we want to manufacture another one, and if we can minimize the change, the tolerances, and so on, that's how we define quality. A controlled manufacturing process for hardware, we get very little variance between each unit we manufacture. So that's what we call quality. And with hardware, if we can minimize the variance, we increase the value.
Hmm.
But with software, since we can deliver updates over the life cycle, if we can increase the rate of change, that delivers value. So these are opposite. And it's one of the reasons why I think we observe that companies that are really good in hardware struggle to do software, and vice versa.
Yeah, I
So
think that could be at the heart of this. You can't approach both problems in a similar way.
mhm.
And
Yeah, at least be aware of it. So
yeah, I think change, very well said. Essentially, I think that's also the underlying value of software, if you will, that it can change and
yes.
add
Hmm.
value over period of time, and it can change in significant ways. Where and I remember products where the hardware remains same, but the whole OS underneath changed from something else to Linux or from Linux to something else.
Mm-hmm.
So it's like totally reprogrammed the software to do something else, right? Um, so I think
And
the other aspect.
yeah, it's very hard to predict where you're going to end up too, because these are general purpose platforms. You might think the software is going to do X, but 4 years later, the software is doing something completely different. So it's just very interesting to watch how
Yeah,
your product requirements change over time as you learn. Customers give you feedback,
yeah,
so very
right.
hard to predict.
Yeah, so I guess that the change has to be embraced rather than controlled, I think.
Yes.
And speaking of controlled, there is one aspect you mentioned about control. So, what do you mean by control in the product sense, and how does software development and open source fits into that, or how does that facet kind of like ties in?
Yeah, if we look at developing a product, we like to have some level of control over the components or the software pieces we pull in. And the reason for that is simple. If we run into problems, we want to be able to fix them. We want to be able to get support when we need it. And companies like Apple and Tesla have embraced this to the nth degree, and that they try to build as much as they can in house. And the reason they do that is so they have control over it. They can make the changes they need. They can get the stuff when they need it. So that this is always a big concern. If we're pulling in all this software and we run into problems, how are we going to deal with it? And that's really the art, I think, of modern development. We need to get good at using other people's code, reading other people's code, modifying it, um, learning to interact with other people who are working on this stuff.
Hmm. Yeah, I think control. Yeah, that's very important from how you approach the problem and how you view your end-to-end solution. And definitely, I think what we need to do in terms of that you need enough control to streamline the development for your products and understand that it's not about controlling the end-to-end outcomes but more streamlining it.
Yes, and you understand this. You spend a lot of your time debugging build problems, fixing problems, and other people's stuff. So open
Yeah,
source gives you the ability to do that. So for your projects you work on, you're able to go in
yeah,
and do what you need to do.
right. And I think as they get so complex, right, we can't get all the know-how under one roof. So essentially, if you see how software has developed over a period of time, you need like different kind of skill sets, and it's much better in that way that it is distributed. And so there's a way for me to do something that you can consume easily, and you can work with it in your own capacity for your own value, and vice versa. So I think it's definitely important.
Yeah, one of the things I tell people, the superpower in this age is knowing who to ask and knowing how to ask it, because, like you said, we can't. Systems are getting to the point where we can't do it all. We can't know it all,
Yeah,
and and
right.
so being able to work effectively in open source communities is a very valuable skill.
Yeah. So now speaking of this, so I guess these are kind of considerations. Now, I think the most important now, at least what I think is what you also mentioned there, the last was culture. So I guess you got to create a bedrock of culture that you can get all the above handled. So how do you see the culture from how it is evolving and how it is with respect to open source and prior to open source methods. How has it evolved and what are various aspects of it?
Yeah. So I think what we're realizing is with software development, we're really looking for the nonlinear improvements, where you go along, things are improving incrementally, and all of a sudden something just jumps up and there's a big improvement. This could be a new programming language, a new algorithm like the recent AI algorithms. Those are step changes, and that's really the what we're looking for. And these things cannot be forced. You can't just throw a bunch of money and a bunch of people at a problem and just it's not, you can't predict what's going to happen. So what we're finding is the open source environment, that culture seems to be really good at producing these innovations. And the reason I believe this happens is it provides an environment for the right people to connect, and and then they have the freedom to experiment, and then these things start to happen. So it's I feel like the fundamental benefit of open source is really the culture and the environment it provides for these innovations to happen,
Hmm.
versus like getting free stuff, or looking at it in a socialist sense, like we all work together for the better common good. I really don't think that's the core of it. I think the core of it is really the environment where the right people get together and they have the freedom to work on stuff, and then the innovations happen.
Hmm. So I see that there are two ways. One of them being you basically get some software written by some company or organization, and then you go with it. Basically, you buy it, and then maybe you buy some support from it, and then the second approach you talk about is the open source software approach, which means you find out what open source software exists for the problem space you're looking for, and then you basically engage or maybe work with the project community or maintainers or experts in those areas and support them, and maybe have buy purchase some support from them for these kind of projects.
Mm-hmm.
And how do you see that happening? Like, can you contrast these two approaches? Is like, the second approach being more we call valuable, with the people we have worked so far, or how is it? Which way it is trending?
Yeah, that's I think pretty much across the board we're seeing a shift towards open source for fundamental building blocks. And I'll just point out two examples. It used to be maybe 15 years ago, if you needed a browser, you licensed a proprietary product. You know,
Mm.
it could have been Opera or something. If you needed a browser in a device, but more, lately, the open source alternatives have definitely taken over, and that's what you use. Same with operating systems. 20 years ago, Windows CE was popular, and everybody thought that was the future. And Linux was kind of looked down on as kind of a hippie thing or something. But since then, we've seen how that's turned out. Windows CE is pretty much gone, and Linux has taken over. I
Mhm.
think real time operating systems for microcontrollers is very similar. In the past, it was all proprietary. There's been a number of open source alternatives that have emerged, like FreeRTOS and Zephyr, and especially Zephyr. That's just moving at a tremendous pace that nothing else can keep up with that. So it will emerge as the de facto
Mhm.
operating system for microcontrollers. So
Hmm.
I see a definite trend in these basic building blocks that
Hmm.
people are looking to open source to
Hmm.
supply these pieces.
Yeah. Yeah. So I think I also see this as kind of extended or external R&D, if you were to look at that. And
Hmm.
a lot of times, there were big orgs in the past where they had huge R&D, in-house R&D departments, and then I think that complexity just grew over a period of time by leaps and bounds. That I guess this is the best collaboration mechanism that's out there, um, where you basically collaborate with people, and you use the open source as a vehicle to do that. Um, so, what are some of the underlying, principles that makes open source work?
Yeah, I think it's difficult to know for sure exactly why open source works so well, but I think there's a couple things it has. One is doing things in the open. We do better work when it's in the open. And a common analogy is, when we're having guests over to our home, we typically clean up a little better and straighten
Mhm.
things up. It's just
Yeah,
when our homes being on public display, we do a better job cleaning it. So
yeah.
um, and so doing things in the open is a powerful thing. I think also freedom is a very powerful thing as well. When developers have the freedom to experiment and try different things, a lot of these innovations are more discoveries than things that we just will into
Mm.
existence. And some of these algorithms are discovered accidentally. But at any rate, I think freedom's a very key ingredient. And then the last thing I think about is just the opportunity for people anywhere in the world, the right people to interact. You no longer have to belong to the same company or be in the same location. If you have the skills and the interest, there's an opportunity to have an impact. So I think there's a very nonlinear effect with the having the right people involved and working together, such that there's this emergent effect where the combined result is much greater than the sum of the individual efforts.
Mhm. So do you see any challenges or any downsides, or at least some of the concerns that people have with this method?
Yeah, the funding is always a concern, and
Hmm.
we see this from time to time where open source authors are driven by the craft and interest, but they don't really have a business model around their work and they don't have funding. So they may quit working on the project and then that project just kind of withers and dies.
Hmm.
So I think it's wise for companies to audit all the OSS components they're dependent on and kind of investigate the health of these projects and talk to the people and try to understand, is everybody have a
Hmm.
comfortable working situation or do they need funding? And
Yeah.
again, this illustrates why it's important to be a participant if you're using open source software and not just a consumer, where you look at it more as um, if you're participating in the project, you're testing, you're providing feedback, you're interacting with the people in the community, you soon get a sense for the health of the project.
Hmm. Yeah,
Um,
I think that's very well said, because if you look at your OSS consumption and the whole pipeline, whole stack, that you're basically relying on, and make a good chart of it, and then there are several ways to assess the health of projects. If you go on GitHub and how many stars it has, and what is the activity of past 1 year or 6 months, and how many contributors, long time contributors. There are various stats that are available, and it could be that there is one project that you rely on, and then there isn't a huge community around it. It's somebody writing it on his or her free time, and so that's also basically finding out your single points of failures, or I wouldn't say failures, but it's also like you'll have to take a reactive action if something happens to that project. So I think proactively looking through your dependencies, I guess, is a wise advice. I think it's a good
Yes.
thing to do.
We routinely hear people doing this to check for licenses, but I think also project health is a good idea.
Yeah, I agree, and I think it might be interesting to build a stats around that, like what to check for.
Mm-hmm.
I think that's probably a topic for another podcast, but
Yeah, and possibly a tool.
possibly a tool.
Yeah.
Yeah, so I think. Um, so how would you sum up, in terms of, the culture, or a few nuggets for people? What should they look for, or how can they become part of, or adopt, embrace um, open source development methods?
Yeah, I'll just read a sentence from the blog post here that I think
Hmm.
provides a nice summary of kind of the thoughts around this. And the benefits of open source are not primarily in getting stuff for free or pulling resources in a socialist sense for the greater common good, but rather providing an environment and connecting the right people for innovation to happen.
Mm.
And this dynamic has happened occasionally in the past in companies like AT&T Bell Labs and
Hmm.
Lockheed Martin Skunk Works. So we have seen amazing environments of innovation in the past, but I feel like most of those have moved into open source. I'm sure there's still exceptions, but for most of us who don't have vast resources like AT&T did, um, open source gives us like you said, a kind of an external R&D, advanced R&D wing. And I've concluded that companies don't engage in open source out of altruism, or like Google and Facebook, they don't do this just because they're nice people. They do it because there's a business return.
Hmm.
And Google has 27,000 engineers,
Hmm.
and with that number, you'd think they could write any software they need. They could just create it, but they can't. They have to go to open source to get the technology they need to move forward. And as companies like Google, Facebook, Amazon, Microsoft, if they're doing it, how much more us smaller players need to be engaging and doing this as well.
Mm. All right. I think it's a very well written article. I think I would encourage everyone to read Cliff's blog on this. And with this, I would like to thank you for listening to us today. And I think we will post the link to the blog in the notes section. So thank you very much.
Yes, thank you.